Hey guys, so for today we are going to be learning on Newton's third law. Alright, before I move on to explaining on this question regarding the Newton's third law, I'd like to state and clear it up what Newton's third law is exactly. So now, let's have a look. Newton's third law of motion. Okay, it is quite direct, this law actually. So what does it state? It states that every action force has a reaction force that is equal in magnitude but opposite in direction. Okay, so basically Newton's third law of motion states that every action force has a reaction force that is equal in magnitude but opposite in direction. So literally, for example, like let's say you were to push your hands against a wall, okay? You were to push your hands against the wall. So there's a force over here. And there is also a force by the wall towards the hand. So there's also a force over here. Let's say this is A and this is B. So force A towards B is equal to negative force B towards A because it's in the opposite direction. The forces are just the same. It's basically every action has a reaction. Okay, so that is to clear up things about Newton's third law of motion. So now, let's move on to an application question in order to make sure you guys understand the concept clearly and in order to apply on various calculations questions. Okay, now let's move on to this question. Okay, the moment you get a question, do remember to draw a free body diagram. Exactly. There's two options over here, whether you want to draw on top of this particular diagram or draw beside it. Okay, it's up to you. So for this question, the free body diagram, let's just sketch first. New normal. Over here will be your weight force. Okay, that is good enough. Let's sketch the free body diagram. This will be your object. Normal force is upwards. Weight force is always downwards. Please draw these two forces here first because these are one of the most important and easiest force to actually draw. Next, okay, these two forces are the most significant. For us to know the next forces, we have to read the question first. Okay, a block of mass 200 kilogram. Okay, kilogram is in SI unit, so let's move on. Is pulled along an inclined plane of 30 degrees. 30 degrees by force of 2 kilonewtons. Please remember to change it to newtons as shown in figure 4.46, which means it's 30 degrees inclined. Okay. The coefficient of kinetic friction of the plane is 0.4. Okay, what do they mean actually over here? So you guys know previously we have learned about kinetic friction, which is a force to frictional force. So we learned that Fk equals to mu n. Mu over here is called the coefficient of kinetic friction and its value given is 0.4. At times you have to find the value, but over here the value is given. Okay, so now let's move on. The moment you see something which is inclined over here, 30 degrees, this is our main one, okay? Let's have a look at our main angle first. 30 degrees inclined, which is levitated or which is above the ground or the earth's ground. This is basically the flat ground, because if flat ground, you punya weight will be directly downwards, right? 90 degrees, okay? But right now, it is levitated or inclined by 30 degrees. Sebab itu, your weight is not straight. Your weight is miring macam ni. Dia tepi sikit. Jadi, what is the angle between yang sepatutnya di bawah? That is 30 degrees. Okay? As simple as that. Okay? Sepatutnya 90 darjah. Tapi sebab dia incline 30 darjah, sebab itu, dia punya weight force sepatutnya bawah kan? It is bawah like this kan? Tapi remember, there's a 30 degrees difference. Okay? Because it is inclined. Alright? Tapi jangan risau, this weight over here is memang directly towards earth. but in your diagram, it is 30 degrees inclined. That is the only difference. This one is directly towards Earth because of gravitational acceleration. Okay, don't worry about that. Okay, now next, for this force over here, if you guys realize, you guys can even draw an axis over here. So it's 20 degrees, right? Automatically, it's 20 degrees. Okay, please remember. Okay, untuk weight force ni, let me give one tip. Let's say your object is 40 degrees inclined. So your weight is still directly to planet Earth. But remember, the angle which makes up this inclined plane is 40 degrees towards y-axis. Kenapa y-axis? Sebabkan weight force patutnya directly downwards using the y component. Exactly my point over here. Okay? Alright, so now you guys have your free body diagram. Let's draw the table of forces as we usually do. Okay, now over here, as usual, your forces, your x component, your y component. Please label full, okay? Force, you will have your external force, frictional force, okay? Next will be your normal force, and next will be your weight force, okay? So now, in this particular subtopic, we will be learning on action reaction, right? Okay, so don't worry, over here for this particular topic, same thing, summation of forces or total of forces. Okay, it's just the same thing, summation of forces and total of forces. Okay, it's equals to 0. Okay, now the acceleration is towards the right? Because the external force is moving that side. So acceleration will be in your x component. Exactly. Okay. So now, same thing over here, MA. Alright, next, let's fill in the blanks. F over here for x component, you will be doing here because it is 20 degrees above, so here will be your F, right? F cos 20. For your y component will be F sine 20. Same thing inside your table. F cos 20 degrees, here F sine 20 degrees. Okay. Why isn't it not negative? Because your movement is towards the right. So this is right and this is up. So it will be positive. Okay. Next, for your frictional force it's opposite, right? The moment it is opposite, it will be negative Fk. Okay, it's in your x component. Why? Because the object is particularly traveling on your x component, no y component. Okay, you can even write negative mu n over here. You can convert it directly because you know very well frictional force is equals to mu n. Next, normal force, x component none, y component is positive n. Weight force is negative W sine 30 degrees and negative W cos 30 degrees. Let's have a look again. Yes, 30 degrees over here. For you guys to know this one, it's negative because it's downwards, okay? So it'll be negative sine 30 degrees for your x component, negative cos 30 degrees in your y component. It's just opposite, okay? Now, what does the question require us to do? Find the normal force. Okay, for us to find the normal force, what do you guys have to do? Since the normal force is in your y component, it's as easy as summation of y equals to 0. Sorry, summation of forces in your y component is equals to 0. So what you need to do? You need to F sine 20. Force is given just now, which is 2000 newtons. Please convert it, it's given in kilonewtons. Please convert it into newtons because that is the SI unit. Next, normal force you need to find. Weight, you know very well, weight is equals to mg. Is the mass given? Yes, the mass is given. Gravity, you guys know very well, is 9.81. Remember, there is already negative. Do not put negative 9.81 in your g. You have already represented your g with a negative outside here. Okay, so you'll find your normal forces value. Okay, so for your normal force, the answer will be 1015 Newton. That is for the first one. Next, for the second one, they asked us to find net force. Okay, the net force over here is in your x component. Why is direct? Because the net force is directed along the inclined plane. If you see over here, it is moving along the inclined plane on the x component. That is why the net force over here will be in your x component. Okay, now you guys know very well. Here you have to plus with this and with this. Okay, over here in this particular section, force net, this is for your second question, okay? Force net is equals to summation of Fx. The net force is directed along the inclined plane surface. Therefore, force net is equals to summation of Fx. Okay, so you guys just need to total up the force over here. That will be your force net, because force net equals to summation of forces. Do not include this thing, okay? Do not include MA. Okay, that is because they ask force net only. Now they are asking the acceleration. The moment they ask for the acceleration, that is when you can include force net or summation of Fx equals to MA, which means plus all of this. Basically, the answer from the previous question equals to MA. Find your acceleration. Okay, that is how it works. Next, for question D, the time taken for the block to travel 30 meters from rest. Okay, I guess you guys have multiple formulas from your second chapter. V square equals to U square plus 2AS, S equals to UT plus 1 over 2 AT square, and so on. Use this formula to find your time. Okay, your time would be 4.94 seconds. All right, and for your previous question, which is your acceleration's answer will be 2.46 meter per second square. All right, guys, I hope you guys enjoyed this session, and this session is specifically speaking on the third law of Newton. All right, and it's not basically about the answers, it's basically about the techniques and methods and understanding process in order to get your answer. Okay, guys, I hope you guys enjoyed this session, and I hope you guys understood about the Newton's third law well. Okay, thank you very much. I hope you guys have a great day.